Okay, welcome you back for the last session. Also an interesting session that we will go through now. As usual, I'll share my screen and take a look at the presentation. And so like I mentioned, this is our session number 8. We'll talk about research topic on sensors, and we'll cover the interdisciplinary area. I think a lot of the times when you talk about sensors, by themselves, they are not that useful, right? It needs to be able to be part of a system. And when that system, it can be part of a chemical plant, it can be part of an agriculture setup or an environment like industry and so on. So interdisciplinary is definitely going to be an important characteristics of the research topic. I think, like we talked about, it is an important one. And some of the areas that we will take a look at are sensor research and speech research. There are many other interdisciplinary areas that are available in applied physics. I think we looked at them in the very beginning of the lecture series. But specifically for today, we'll focus on the sensor research and then a little bit on the speech research, and then open it up for any questions and then discussions. Be back. Okay, so like I mentioned, interdisciplinary is here, and collaboration is the key, and solving real life problems and helping the community. I think this is what the industry is and the research community is trying to do. So, more to add to that. So we'll take a look at sensor research. At this point, what I'll do is I've given a URL here where they can go take a look at the sensor journal and really take a look at the recent activities as recent as this month, and we'll read together some abstracts in terms of how applied physics is used in sensors, and hopefully that will give you a bit more motivation. And then offline you can go read the whole paper and understand what the problem that they have solved, and what some of the challenges that they faced, and what some of the future work could be, right? I think we'll take a look at them. So I think there is some more people waiting with me. Bring them in. Nobody there. Okay, so got it. Okay, so let me stop sharing and then go to share my screen so you can take a look at the actual sensor research paper. So let me share my entire screen. And specifically, we can go take a look at. So this is the sensors journal, and as you can see, they are now focusing on in this particular issue, which is February 2022. As you can see, there are so many articles, like close to 400 articles. So that shows you the active. The sensors is a very active research area. This is why we want to thank Madam Shubhashi Madam for picking this field, this particular topic for our lecture series, which is very, very active right now, and it touches upon every field that you can think of, right? I think this is the beauty of this topic. So I think if you take a look at that, right? I mean, specifically they are looking at underwater energy harvesting and how the sensors that are inside under the ocean, how important they are and what are their important characteristics. So as you can see, to obtain the vital signs of the planet and global climate change, constant information from different locations is crucial, right? I think, and for that, low-cost sensors. We talked about the cost. I think somebody asked a question about the affordability of sensors. Even for industry, the cost is going to be a very important factor. So low-cost sensors and high-energy autonomy are essential in the ocean. Additionally, submerged sensors are extremely important to acquire and analyze real-time data, and in this way to help to make the most appropriate decisions and choices without compromising the environment and the humankind. So basically, in order to have a very clean environment, I think you might have heard about a lot of ocean garbage in there, and how do you make sure that the ocean is kept clean? And a lot of them can be now using the sensors. We can make some more progress. So the autonomy of submerged sensors located in the ocean should be increased. I think they're making the case for that as imperative to minimize battery replacement. We talked about the battery life. they're definitely bringing that out, that you don't want, let's say if you have a sensor that is kept submerged inside the ocean, you don't want to go every day and change the battery. That is not practical, right? So having to have very long battery life is definitely important due to the undesirable logistics. That's what we talked about, and high cost associated, right? Anytime you want to go under the ocean bed and access those sensors, you need to send a human, and you need to send a vehicle and a human to go there. So these things could be very, very costly. And the minimum amount of energy needed for the sensors and the correct use of energy measurement management makes it essential to develop optimized submersible energy harnessing device based on linear electromagnetic generator. So I think the purpose of me reading this whole thing is to give you a motivation that you, with a background in physics, can do a lot in this space. I think you will see some of the articles that they talk about here. They're all scientists. They're not computer science people or anything like that. They are pure applied physics and with multidisciplinary. Some of them could be in chemical engineering, some of them could be in mechanical, but a lot of them are involved in pure science. So let's take a look at some papers. I think in my slides, I think I covered a few of them. Let's take about in ultrasound guided ways. Let's take a look at that part. So here is one methodology for detecting progressive damage in structures using ultrasound guided waves. I think they are talking about an aircraft structure, and as you know, aircraft has got many components, and any structural damage on the body of the aircraft could be very devastating. So damage detection and structural health monitoring, metallic and composite structures, right, depends upon several factors, including sensor technology and the type of defect that is under spotlight. So you can go and read that more. So I've kept the URL or the link for this particular sensor research journal, and I would highly encourage you to go take a look at that if you are interested in doing further research in sensors. So here they talk about ultrasonic guided waves and methodology. I think we briefly covered them, right? In the even in the home smart home use case, we talked about ultrasonic sensors for motion detection. Here they are using the same type of technology, but to detect progressive damage and corrosion in aircraft structures. So these are real life use cases, right? When people are willing to pay lots of money in solving this type of problems and making sure that these things are caught before it becomes a disaster in the airline industry. So especially when there are slow changing conditions, as you can see, there is several materials involved, like aluminum and carbon reinforced plates are placed together, and they create these scenarios to see how quickly it can corrode, right? So when I talk about the interdisciplinary, this is where the physics and the material science aspect of it comes into picture. And then you have a sensor that detects the corrosion, and how do you detect that in the right time, and then how do you communicate that. The setup was completed by an array of 10 piezoelectric transducers. You would have probably heard about them in your lab, physics labs. So these are all traditionally used in physics labs, but here is an example of how they have used that to solve a real problem of identifying structural damage in an aircraft. And so that's one more thing. So I think they go into talk about hardware is able to process the raw acquisition. And then remember, we talked about sensors. The reason why we picked this topic of sensors and IoT, sensors can sense some characteristic, but unless you communicate that or transmit that data for further analysis, it is useless. So I think this is what this article is talking about. The hardware was able to process the raw acquisition to minimize the transmitted data conducted over 8 weeks, and then they go into the details of how the pattern recognition, pattern matching algorithm. So eventually they basically said this is how they solve the problem of identifying defects on the aircraft. And then so here you can go read the whole article if you are interested. It's quite fascinating to see how many different technologies and science concepts are coming together in this vast field of sensors. You can also go take a look at some figures here. So they give you some examples in terms of how they assemble the whole hardware, and then they also talk about the actual setup that they have. So they give you a lot of information on how they have done it. What is the hardware algorithm? How do you send the signal to it? Once you send the hardware, then there's a pattern matching, and then the pattern recognition, and then you send it for further analysis. So yeah, please go through this. They are very they publish their exact output. A lot of information here. So I thought this will be an interesting one too. So something that we have already talked about in our lecture series about importance of ultrasound waves and how we can use them for something very useful. So here is an example of a industrial IoT use case. So this is one thing that I thought will be quite interesting. Let's take a look at the second one. If you just read that, right, determination of binary gas mixtures by measuring the resonance frequency in a piezoelectric tube. Again, the piezoelectric technology is heavily used. Again, these are all based upon physics and applied physics, so you can read more here. Here is an example of applied physics and some chemical engineering involved, because you are measuring the gas component of it. We talked about the detection of gas leaks in oil fields and another industry setting. Here is an example of that, right? The composition of gas mixture may be derived in speed of sound. So basically, this is so fundamental. By just purely observing the changes in speed of the sound, they can understand what type of gas mixture that it has. So they send this sound wave through the gas chamber, and then they will measure the speed of sound to determine the composition. So it's quite fascinating to see how they do that. Again, we'll not go into all the detail, but again, if you are interested, please go through them. Here is more article. You can take a look at some figures here. They give you the setup in terms of how they have done it. Here is the gas in. You have the piezo tube that takes it amplifies the particles and the materials in there. Once you have it, then you analyze it, then you acquire, basically you take the data out of that, and then you send it for further analysis. So I think a lot of useful information here in this particular article. So it's an international journal, so you can even reach out to those researchers. I mean, one of the things when we were doing the PhD, this type of facility was not available, right? One has to go to a library and then wait for the article to show up a month later. And you cannot contact any one of these researchers those days, like 20, 30 years ago. It was nearly impossible to talk to any one of them. You need to write them a letter. Well, that's the only thing that was available. There was no computer, no email, no phone call, no WhatsApp, nothing. But you folks are really, really fortunate, right? Here is their email address. So you can go talk to Karnika Manivasagam and say, hey, how are you doing this particular research? This is so powerful. The information that you have is so powerful. So use it, and then each one of them gives you a different perspective of what can be done. If you want to do apply your knowledge in physics into sensors, then sky is the limit for you. Okay, so I think the whole idea of showing you this is to motivate you to. If some of you may be interested in doing your PhD in physics, postdoc in physics, then this could be a great starting point. Let me see. I think I also took one more example. Yeah, I like the oceanography use case, and then the measuring gas was the second one. Then let me take a look at the other. This is an image registration. I think this is something that I liked as well. So let me go there. So we'll find that particular article. It's called image registration. So there, like I said, there are close to 400 articles in that journal. So I don't think we'll have time to go through all of them, but some of them might be interesting. So here is an example of again, this is the distributed array ISR. This is image-based sensors. How we can use a camera for 3D image recognition and construction. This could be another example of of a sensor technology that is needed, right? So this is all about optics based. If you are interested in camera and lighting and things like that, then you could apply those techniques for image reconstruction. So here is one example of that. Okay, so they give you more information on how they take different images, how they extract features in this image. By the way, my PhD was also on image recognition, so it's near and dear to me. So when I look at anything that is related to image recognition, that always fascinates to me. So because anytime, a lot of the times you get the way we perceive things is through eyes, right? So we take lots of billions of pictures through our eyes, and that's how we recognize them. And trying to simulate that in a computer is a nightmare. So, but it gives you a sense of how good our brain is in recognizing them, and only a fraction of what we can do as humans, the computers or the systems can do. But what that means is there's plenty of work. I mean, researchers like you are needed to come in and solve these complex problems where multiple image sensors trying to sense different parts of an object and trying to make sense out of that, and so that could be a fascinating field as well. So like I mentioned, tons and tons of example there. Uh, like I said, you can spend hours and hours in understanding what this journal is. You can subscribe to that. You can subscribe to their email list. You can get the email notification with all the information. So it's all in your fingertips. Okay. So that is one thing that I wanted to share on the research side, on the sensor research side. Then I think the water cloud detection is one more example. Again, these are all related to weather, environment, and things like that. So great examples of where applied and sensors can make an impact in the environment. Then I think I want to spend a little bit of time on the speech analysis. Speech analysis is from this article. Let me go there. See if I can take a look at that. So I think we briefly talked about the natural language processing. So here is an example of how speech analysis can they detect early form of cognitive decline. So especially in elderly, when as you age, your speech could vary. So here they have done some study on. It's definitely an interdisciplinary area where applied physics and speech analysis plus doctors and neuroscientists were involved, psychologists were involved to understand how variations in speech, right? The way, for example, one could take somebody's voice over a period of time as they get into later stage in their life, let's say 70 plus or 80 plus. Then you understand from their speech, whether they are getting into early form of dementia or any cognitive decline. So I think there are great research areas as well for applied physics. So this is something that I thought in one where it combines the speech analysis and cognitive decline. So yeah, if you're interested in that, you can go through that. I think they have given tons of information in terms of how they have done the speech analysis, how they collected the speech sample, how did they process them, what kind of analysis that they did, and then how did they fed it through the NLP process, right? They need to say and things like that, right? So a lot of the words that the elderly would use, they would detect based on. So I think this is another example of how research can be done. So I think that is on the research side. One other topic that I also want to touch upon. Just a moment. I think somebody is not muted. We mute on. That way we can keep the background noise to a minimum. So we talked about the sensor research and the journal and the articles and so on. There is also a conference that I wanted to show you where they are focusing on sensor for industry. Let me just bring that up, and then I'll open it up to questions. Yeah, here it is. Okay. Yeah, so I was just going through what conferences were available for sensor. So there's Sensors Converge is a conference here that is happening in June in San Jose. So here is an example of all the activities that are happening in sensors, so you can get more information. I think we touched upon in our course or lecture series. They're talking about the same thing: sensing in automobile, robotics, industry, medical, smart cities. So they're all part of this conference. So this is another great area where you can get more information on, what the industry is doing, right? In the previous one, we talked about the sensor research journal, what researchers doing here in the industry, how is companies are investing in sensors and in different areas. And you can go take a look at this also. And if I'm here, I'll probably go and attend this seminar here or the conference and hear more information on. Let's take a look at some schedule, so we can take a look at them, and we can see the areas, right? You can all the area that we talked about: aerospace, agriculture, industrial and manufacturing, and interoperability, right? The sensors need to interoperate, things like that, networking. So I think lots of information here. You can also take a look at who's speaking in that. Take a look at. You can even contact some of them, right? I think there's a beauty of this is you can talk to Gaurav Bansal. He's from John Deere. It's one of the largest earth-moving equipment that is used here. We can talk to them and say, what does he think about sensors in manufacturing. So a lot of information here. So I thought this would be an interesting one to take a look at it as well. And then there is an expo hall exhibit. So please go through that. In the conference, you can see all the. I don't know whether they have all the conference papers ready or not. I think a lot of the things that we talked about are relevant, right? We talked about 5G. So clearly, the sensors, right, are driven by 5G. So how 5G will impact sensors. So this could be a great conference. So if you want to extend what we talked about in our lecture series to industry, so let's say you want to go join a company, then these are some other companies that you can take a look at. And IoT is a big thing. Yeah, I thought this will be an interesting one to take a look at that as well. Okay, I think Madam asked a question about what can students do in terms of projects and research. So project, we talked about some of the you do it your own. We shared some kits in Amazon. That's something that you can just go purchase and play with it. If you want to do more on the research that Madam talked about, these are the two areas at least that I found that could be quite useful. I'm sure that if you search more, you'll find a lot more activities in sensors, because without them, many industries cannot progress, cannot advance. So it is so fundamental to many industries. Okay, so I think that is all I had. Let me now stop presenting and see if you have any questions. If not, I'll just quickly go through all the sessions in a kind of a fast-paced mode so that you get a refresher. So if you want to, there is an assessment after this. So if you want to refresh that, I'll just quickly go through that. That might help you answer some other questions. But before that, let me pause here, see if you have any questions on the sensor research and the sensor conference that we just briefly looked at. And if you have any questions, please unmute. I think I muted all of you because there was some background noise. But please unmute and ask a question, or you can always type it in the chat room. Either one is fine. So, okay, if there are no questions, what I'll do is I'll do a quick walkthrough of all the sessions and then kind of refresh your mind, and then we will wrap it up. Okay, so that's what we'll do. Let me present all the sessions in So just to recap, we started our first session talking about applied physics and IoT. We look at sensors and communication, and we look at course overview. Basically, we talked about why applied physics is enabling the technology, what is Internet of Things, mobile 5G communication network. We talked about private networks. Then we looked at two industrial IoT use cases: manufacturing and smart cities, automobile and agriculture. Then we looked at consumer IoT. Then today we focus more on the speech analysis and recognition, and then what are the active research areas that are happening in the industry. So in the applied physics area, we looked at three areas, like electrical, electronics, and communication. I believe those are the three areas where sensors are typically used. And we talked about monitoring power grids, sensors of many types: temperature, pressure, humidity. We talked about antenna theory. So a lot of interesting stuff that we covered in the first, including the mobile telecommunication technology. We started with 2G, now we are in 5G, and how 5G and IoT are driving the private networks. So private networks are nothing but you can have your own network in a manufacturing plant or in an apartment building, as opposed to having them part of Geo or Airtel. So those are the primary driving force for IoT and sensors. So the second day, second session, we delve a little bit deep into IoT. We started understanding what they are, what are the two broad categories of IoT: consumer and industrial, and some of the characteristics of consumer IoT, characteristics of industrial IoT, especially the Industry 4.0. The factory automation is what is driving the industrial IoT there. We took a look at many examples of IoT in the industrial. I think this picture, we spent a lot of time on it. Then what can you do in IoT? I think we asked the question, and then we talked about taking a look at whether your water tank is full or not using sensors, and then air quality in your campus. So we looked at some examples of what you can do as a science project, either at home or at your college, in the labs, what you can do. So that's what we looked at in second session. Third session, we primarily looked at 5G. Why 5G? What are the characteristics of 5G? It's just not about speed. It is about ultra low latency. So you want to have application that need data right away. And so that's where the importance of 5G came into picture. And some of the leaders and what are the mission critical aspect of it. The massive IoT is what is driving the 5G uptick in many companies and many countries. We took a look at private networks in many use cases. We also introduced a term called edge computing, which is something in between a cloud and a device. That's where basically the computing and the analysis and the processing should be very close to where the sensors are, rather than in a distance in a cloud somewhere on Microsoft Cloud or Google Cloud or Amazon Cloud. So this edge computing, today it might sound like a technology term. In a few years from now, it'll be as ubiquitous as cloud is today. So we introduced that part, and we took a look at what are the edge gateways and how they are applying in the IoT in the sensor field, because they are the ones who connect the sensors to the rest of the world, the edge and the IoT gateways. So we talked about them, and Microsoft and Amazon are the leaders in the edge market, and what we are doing in our college lab, in the IoT lab, I think we covered that also. So that's how we concluded session 3. Session 4, we focus mainly on manufacturing, and so what are the typical manufacturing flow from the enterprise point of view? What type of sensor protocols are used, sensor types are used, and whether it is used for control or measurement, and all the verticals, whether it is in hospital or retail or logistics and so on. So I think I think we spent a lot of time on this slide, understanding the various types of sensors. I think you saw some of them in the research conference as well as in the journal as well. So it's very active. And yeah, I think some of the key characteristics we talked about: long battery life, very rugged in the case of an industrial IoT, because they could be sitting in an oil field or in an agricultural land where it's not inside an AC room. So we covered that in session 4. Session 5, we spend more time on these three areas: smart cities, automobiles, and agriculture, and what are some of the challenges in each one of them, right? When a smart city needs to bring lots of these sensors together, whether it is for the vehicles or the pedestrians or bicyclists or for the buildings. It doesn't matter. Many sensors come together. So it's a very challenging, large scale projects, and I think our government has created a lot of initiative. I think I mentioned Coimbatore is part of this initiative. You can go check them out, how they're doing smart cities in Coimbatore. And then we spend a lot of time on automobile, whether it is fleet management, kind of vehicle connection, vehicle to vehicle communication, maintenance, autonomous driving, and infotainment. So lots of use cases for sensors. And then spend time on the agriculture, how crop management and moisture control and things like that are essential for agriculture. Then sixth segment, we spent time on smart homes. We looked at typical, not typical, some of the sensors that are used in modern homes and how they are relevant, and some of the motion sensors technologies we looked at from the physics point of view. Some of the passive infrared, microwave, ultrasonic, vibration. We gave use cases for each one of them, and then we gave some examples of smart home one, and then I walk through a pool monitoring system at my home. I think that's how we concluded yesterday, and then today we spent time on the push to things, on the voice, and then finally we looked at the conference, sensor conference, as well as a journal that is focused on sensor research. Okay, so I think we covered a lot. So hope you were able to assimilate a lot of this information. And I think I've shared all the slides with Madam, and we've also recorded. So if you need any further, please contact Madam. So with that, let me stop here, see if there are any last minute questions on any one of these sessions that you heard in the last 8 hours. Please do let me know. And like I mentioned, this is not the only forum. If you have any additional questions, feel free to drop me an email. I'll be more than happy to assist you. With that, I'll stop talking, then hopefully start listening to you. Okay, if there are no questions, Madam, I think we have concluded our sessions. So maybe we can start wrapping it up.
Thank you, sir. So Subhashri ma'am told about the assessment right now, isn't it, sir?
Okay.
I'm just checking with you, sir.
Sure.
We are having the assessment right now. Madam will share the link.
Sure, Madam. I think Madam was going to do the attendance link as well as the assessment link, I think.
Okay, sir. Okay. Hello. Hello.
Yes, madam.
Sir, is it over, sir?
Yes, madam. Yeah, I think we just
Okay.
concluded.
Yeah. Okay. So thank you, sir. Thank you. Now I am going to put the assessment link as well as attendance link. So I want everybody to complete immediately. Just a minute. Thank you. I have posted the assessment link. Please start your assessment. After 5 minutes, attendance link will be posted. Only 10 minutes to complete your assessment. After that, the link will be closed. I have posted the attendance link for today. Please fill that also. Yeah, the assessment will be closed in another 2 minutes.
Ma'am, those have complete.
Okay, so I hope all of completed your assessment and attendance. So based on the eligibility, that is, we will be taking the consolidated attendance for all the 8 sessions and the assessment mark, and you will be provided with the certificate based on that, right? So now it's time to give a thanks to our sir, our instructor. So thank you, sir. Thank you for a wonderful session, and thanks for readily accepting my invitation to do such a course for our students, for the benefit of our students. Amidst your busy schedule, I think you are traveling here and there, right? Last week you were in here, and now you are there, right? So even in spite of that, the commitment you showed towards conducting this is very good. Thank you, sir. Thank you. Thanks a lot. And I thank all the participants for making this first international lecture series a grand success. I thank the department, and I also thank the management, all the executives and other staff members who have helped to conduct such a wonderful lecture series. Thank you. Thanks one and all.
Thank you, madam. You're welcome. It's been my pleasure to help the students and the college. It's been a wonderful set of students and this topic that you have selected, madam. Thank you
Yes.
for your guidance and your visionary in selecting this wonderful topic. We learned a lot in this session, so without you and your support, this would not have been possible. Thank you again for you and the entire college staff and madam as well as the student. Thank you, madam.
Thank you, sir. Thank you. I will share the assessment and other details with you.
Thank you, madam.
Thank you. Thank you, Alma. Thank you all.
Thank you all.
Thank you, sir. Thank you, sir.
Have a good day.
Thank you, sir.
Thank you,
Thank you.
sir.
Thank you. I'll stop the recording. Thank you.